I'm Lisa Bailey.
And I'm Patrick Bailey with iQlist.com. Today is April 14th, 2018, and this is Manipulative Monday, even though we don't record them on a Monday. But we're going to try to figure out what manipulative can we make or find to 3D print that will help kids learn their geometric shapes. Okay, first off, what is a manipulative, and why would you want to use them? So, manipulative is just something you can hold in your hands that can help you understand a higher concept. Like printing out these shapes, or printing out like, atoms, or printing out, the last time we had those tens places and ones places, just anything that you can hold in your hand that can help get a concept across. So, chemistry, things that you can do. And so that's what they are. And so it greatly enhances your education to try to understand things. We use them all the time. And now if you have a 3D printer, you can probably print some of those things out. And so why are we doing these videos? Well, we homeschool. We have a 10-year-old and a 14-year-old that we homeschool. And we think the 3D printer is going to be awesome for STEM stuff. Science, technology, engineering, and mathematics. I mean, that's very obvious for those things. But I think it's also a great tool, even if you're not going to go down that avenue or not go down that avenue very far with your kid, that you can actually still use it to print out manipulatives to help enhance your education. Like printing out, in this case, we're going to do shapes. But I think there's a lot of things you could do, like, print out atoms or print out
DNA.
DNA. I'm looking at the DNA thing we printed out that's not that good. But you could print out things like that to help get concepts across without having to learn how to, you don't have to want to pursue robotics to use a 3D printer. You can use it in this manner to help you enhance your homeschooling education. And so part of these videos, we're going to... Lisa's going to try to challenge me with things that she needs or thought she needed in the past, or things that most people would need for homeschooling that have crossed her mind. And I'm going to try to create those. And also I'm trying to challenge people who are watching this video to try to create them too. Because wouldn't it be great if a lot of people got together and started making tools for homeschoolers and for people who go to regular school that can help enhance their education, that they can 3D print that they otherwise can't buy or find. And so I think that's a really cool thing. And so... So with that, the next thing I want to talk about is praising someone who actually took on my last challenge. Okay, so I want to kind of go over our last challenge that someone actually took the challenge on, aside from just me. So I was kind of impressed by that. I didn't know how many of these videos I'd have to do before someone actually took the challenge and actually did it, but the first one did. And the person who took the challenge on was Osloy. And he's the one who introduced me to OpenSCAD in one of the videos I did. He commented about OpenSCAD. And so he took on the challenge. And down here on the video, you can see our prior video. You can see he's got a link down here. And he actually stuck the code out here that he stuck for that challenge. And that challenge was to learn your place values. Right? That's the right word? Mm-hmm. Place values. And so if I go over here to where he had it, you can actually go over here and I think you have to right-click on the raw here. That's one way to do it. And it'll open it up into, this is actually the OpenSCAD code to actually create that. I'm not going to go over OpenSCAD in this video. I did that in another video, so you can go watch that or go find some other videos on OpenSCAD. But this is the design as code. So just to show you what he did, I can copy this, and I opened up OpenSCAD. I'll just paste all this in here, which I'm not going to go over what this all means, but that's the code that defines what he designed. One thing he did show me is this FN value, which happens to be set to 100 right now. That's kind of how detailed you want the picture. And so when you want to do the final one, you want to have that a higher number, like 100 or 200. But if you're just fiddling with it and changing it, you don't want to use that because it takes longer to render. So he suggested doing it down to 30, which he put in his code here. So I'll comment that out and put the 30 in. And here he has the ones place. So if I go up here and hit render, the render button up here, this will actually render what he designed. And so he designed these little... Oh, and I learned another thing. If you right click in here, you can move it. I didn't know you could do that. I was trying to figure out how you can rotate. You can just click, you can left click normally and do this rotation. But right click, you can actually move the whole thing around, which is nice to know. And so he made these blocks that are stackable, and he also made them a little different. Here, let me go. If I go to the tens place, So rather than being a number, he actually made them a physical size.
Cool.
So, yeah, that sounds cool. So there's the 10. I remember just looking
at... You can stack them.
And you can stack them. And so I guess the idea is you do them in different colors, just like we did. But also they represent a size. So the person can see this is not the number 10, but this is actually 10 as a physical size. And so that can teach...
Because you put 10 of these together and you have a group of 100.
And you got a group of 100. And so if I comment out it's 100 and if you're not familiar with code, when I do these 2 slashes in here, that basically says ignore this line. So when you see this turn green, that just means it's text and it's not part of the code. So if I change it, so now would render the hundreds according to his code and run it. It'll take it ran pretty quick that time.
Cool.
And so there's 100. And then so you could print those out and they would just kind of stack. And so kids could see the size of stuff. And so he also mentioned, he was talking with someone, he thought this would be a good thing for different types of numbers, for doing like binary, which goes in by 2s, which I taught my kids binary last year, and it might have been good to have something like this with binary so they could see the size, because 10s at their age they understand, but binary is a little different. And so if they had the size, that might have made more sense to them. He was mentioning that. I was like, that's probably a good idea. So I am just excited that someone did something that quickly. I thought it'd take, I don't know, I thought we'd have to do at least, I don't think anyone would have done anything for 2 or 3 months, and we have to do 3 or 4 or 5 videos. Then finally someone would do something, but someone did something quickly. So I'm excited that Osloy did that. I'm really excited. But that's what we want to do with this. We want to challenge other people to make other designs because...
well, what happens if the manipulative that we came up with doesn't work, but Osloy's does for a certain kid? So the more ideas that you have, the more choices people have to use. Yeah. So
that's what I'm going for is, you might have an idea I like the idea we made. I really like that one. But there may be a thing where I make an idea, it's like, well, it kind of works. And someone else makes a brilliant idea or takes our idea and changes it slightly to make it good. Or someone actually prints out an idea and it's good on paper. Like I won't show it right now, but we had something we printed out with angles that someone else made. They're like, this is the right idea. And then it broke. It fell apart. And so if I design something or someone else designs something, you're like, this is the right idea, and you print it out, and then it falls apart after being really used. That's just begging for a redesign. I would like to get good things that are going to last properly and do a good job. So I just want to challenge other people to, a lot of these kids, homeschoolers and schools alike, a lot of schools have 3D printers. And wouldn't it be nice if these teachers who see manipulatives like this go, man, I want that. And we make it easy and simple. People who are geeks like us who want to go design these things, that we can present them to them and showcase it, and they can have these nice tools. So we need 100 people doing things like this because the kids need it. But man, I just want to give Oslo lots of praise for coming up with the design and doing an OpenSCAD, which is really cool. Okay, well now on to, I guess, this week's challenge. Okay, so me and my wife have been talking back and forth a little bit about this challenge, trying to figure out what to do and whether it made any sense. So we're going to talk a lot about this to try to explain what we're doing. But you can say what the actual challenge is. What's the challenge for this one?
So I would like the freedom, the options to make 3D print any shape, whether it is lower primary shapes or your more upper primary shapes. But I would like the freedom to print any shape that I would choose in any size I would choose.
Okay.
And of course that leads to, well, then I can print out as many as I want. Any quantity.
Okay. Yeah. And as we were talking about that, this is for kids to learn their geometric shapes.
So this is more upper primary focus, these geometric shapes.
I was saying ages 7 to 11ish, that kind of but
Yeah, probably your 3rd grade or up.
Okay.
But But that doesn't, dismiss the younger kids. You always have the kids who would learn anything from these shapes. So.
No, or the older kids. I'm not going to focus on the older kids, but if someone wants to take a challenge to focus on the older kids, that'd be awesome, because in briefly talking back and forth, if we were going to print out, say, a pyramid, right? Or a cone, let's make it simple. If you print out a cone for a 8-year-old, there's no point in printing out like a radius and the equation to calculate the volume of the cone.
Nope.
But there totally is a point for an older kid. And if someone wants to take on that challenge or find that, that's really cool. And that would be awesome to do. But I'm going to try to focus on
and we'll probably eventually get there.
Yeah, totally. Because that sounds useful.
I've got a son who could really use a manipulative that would show him how to find the area of a 2-dimensional rectangle, a 2-dimensional triangle, and also the 3-dimensional. So we'll get there, and it'd be nice if he actually had the shape with the equation. So we'll get there eventually.
Yeah, so I'm not going to do that, but if someone else wants to take on that challenge, and when the challenge comes, it's about designing it yourself or finding it. Or you might find something and go, well, that's nice, but I could do better and do better.
Cool.
But also, this is one of those things that it might be, what's the pluses and minuses of just going and buying something? So, and talking to my wife, she had found this a few years ago, and she almost bought it. Some of the things that it looks really cool. It's $18 delivered, and it's got a lot of the shapes that we would want. Mm-hmm. And one really cool thing about this is it's clear and you can see through the bottom.
So it's 3-dimensional.
3-dimensional, and you can see. And as far as 3D printing goes right now, I'm still new and I haven't printed out every single kind of filament you can. I got a long ways to go. But in what I've seen, like I saw the 3D printing nerd recently try to print Benchy in a bottle, which is a ship in a bottle. Mm-hmm. And so he tried to print a clear bottle, and there are some clear 3D prints.
Cool.
And you can't see inside. So he had to switch some stuff around. At the end of the day, there's no way he got anywhere near this level of see-through. So right now, it may change 5 years from now. Maybe someone figures it out, but right now, you're not going to get this beautiful design. That
would be a bonus, the fact that it is translucent.
So that's a bonus to buying this. Mm-hmm. Versus trying to make something. But some of the deficits of this, you said you would have bought it, but you looked at the size, and the size on these are 30 centimeters. 3 centimeters. 3 centimeters. I said 30 millimeters. I'm in millimeter brain. So like an inch to maybe 2 inches for the bigger ones. You're like, I want bigger ones than that. I would like
bigger ones.
She would like bigger ones than that. And then sometimes you might be missing, like I think this is missing, it's either missing a right triangle or an isosceles. I can't
It's
tell.
missing the wedge.
It's missing the wedge. But it's got a lot. It's got most of the pieces you want.
Yeah, because I was looking for the cone. I was looking for the pyramid with the square base. And I was definitely a hard one to find is the pyramid with a triangular base. But a cone is relatively easy to find. A cylinder is easy to find. It's nice to have like the octagon and the different shapes with the sides, so you can start showing sides. And as you start to get into your triangles, to show your isosceles triangle and your right triangle and things like that in a 3D shape.
And the other thing that you would like to have that you can't do with this is to get not only the size you might want.
It's too small.
But also the number you might want, because you were talking today about you were doing pyramids with Kendall and you wanted to build a pyramid out of pyramids. Yep. And you would have needed like 40 pyramids, and you couldn't just go order 40 pyramids. So,
nope.
This thing's being a booger.
So the fact that, this does include most of the shapes that I, as a upper primary teacher, was looking for. But I just thought they were way too small. And we all know the smaller they are, the easier they are to lose. Yeah. And it would have been nice to have multiple of them. Which means I would have had to buy multiple sets. And I had other options that I relied on than buying this set.
Yeah. So if you don't have any of those kind of needs, then just buy this or buy something like this.
Yep.
But 3D printing allows us to probably customize it, get the size we want, and then also print 40 of something if we want at a reasonable price. Now, I'd have to get, I don't know the exact shape of these, but maybe you could print these for $4 worth of material. So you could save some money. But the idea with what we're doing is not the fact of, I can print this out for $4 versus 18, because that's not apples to apples, because this is much better result than I can get as far as that clear. So it's not apples to apples. My point, what I want to do is not about saving money with 3D printing. It's not that it's expensive either, but the point is to create manipulatives that enhance our education, specifically things that you can't get.
Well, and so if I was to sit down with a student and we were going to start talking about these shapes that are just a little bit more advanced and 3D. So we were talking about the cone. Well, for me, I'd bring my student up here and we would actually create a cone, and that student would print it out. And it just seems to me like they would have more buy-in, and they would remember and understand what a cone is compared to a cylinder, compared to a circle, it just, and for some kids, they really do need that, visual of creating, and that the ability to touch it after they've made it. That's really cool. They actually, create it and then they make it, or things like that.
Yeah, I think that's an aspect of it. Like even with our last design, I think if you printed those out with the kid involved, having them see that and having work with you to, hey, we're going to push the button and make the 20 now, and them seeing that, I think would be a big deal versus just being handed it. Even though that in that case they're not part of the creation process of the design, but they are part of the creation process, because they're, it's like they're part of the creation process, right?
And you can even take somebody else's ideas and create what their equivalent is to that.
That's true too.
So you could have a couple manipulatives to help you out.
Okay, so with that, I'm going to try to figure out what I can make, what's available out there. I may even end up finding something, because I don't necessarily have to design something if someone else has made something great. But I'm going to go figure out what I can figure out and then present it here. Okay, so here I think is my solution to all this. It's Tinkercad. Too many people have too many customizations they want to do, so if I try to make a whole set of something, it may not be what you want. So I think the thing to do is to go learn Tinkercad, which I'm actually doing a video on that right now. I'll post it here next few weeks, I guess. But I'll kind of go over this quickly, because let me just go through and make some shapes in Tinkercad, which is an online web design tool. It's free to use. Just sign up for it at tinkercad.com. And it is owned by Autodesk, the guys who do Fusion 360, if you happen to be familiar with that tool. A little more advanced design tool. Also free for small businesses or home education. But let me just go here and start doing some designs. Let me just go down one at a time and try to recreate these shapes. So here I'll just do a cylinder real quick. And I can go over here and I can take a cylinder over here in the tools and just drop it in. There's my cylinder. And I can go down here to a front view. And talking to my wife, she was kind of wanted everything to be 70 millimeters. That was kind of the go-to size. So let me switch to orthogonal here. It just makes it a little easier to view. And I can just resize these. So I can drag this up. Or I can actually click on this box and just hit 70. And let me go back to my home view here. And I see that. I see this first one. It's a little tall, but not quite that skinny. So let me go over here and make this bigger. And let me not do 70 by 70. Let me do, I don't know, let me do half that, 35 by 35. And there's my first cylinder. And over here, I can even click on the color here. And I could make it yellow. Not that it's going to print out yellow, but you can look at it as yellow right now. And there's my cylinder. So now, in Tinkercad, I can just come up here and name it something, skinny cylinder. And then, of course, it's constantly being saved. But now I want to export it because I actually want to create it I want to 3D print it. So here I can go over here and click on export and export it as an Stl file. Just click on that and there it downloaded. I can go to my downloads folder And there's my STL file. So then I can go open up something like, I'm using Prusa i3 Mark III as my 3D printer. So I can just open up Prusa control, and I should just be able to drop this in and create a G-code file for it and actually go render it. So I'll do that right now for this one, just to show you the process. And this is customized. If you're new to 3D printing, if you have a Prusa printer, like I have an i3 Mark III, this is a simple process you can use. However, this Prusa control program is particular to the Prusa printer, and if you try to use it, your G-code would probably be all screwed up for a different kind of printer. There we go, drag and drop, and you can see that relative size there. It's going to be 70 millimeters high. And I can say, yay, do it. Do an optimal 20 and just generate. And that'll make the G-code for it. And then I can go print it out. And I can actually look at what it's going to print, which is, in this case, fairly simple. Print that whole thing out. And I'll save the G-code. I'll save it to downloads right now, just so it's next to that file. And there we go. So now I can take that file and actually go print it. But before I do, because I kind of want to do each one in possibly different colors. So let me minimize that, and go on to the next one. So the next one I noticed was just a big old square. So I'll make a big old square. So I could delete this right now, but I want to make another design because I want to keep this around. So I'll go, what will I do? I guess I can go click on here and go to My Designs. And I can see there's my skinny cylinder. And I can say New Design. So I'll create a new palette for me to work on. And I'll call this Square. Dun, dun, dun. And I'll just simply drag that square out there. Maybe I'll leave it red this time, but here I'll make this 70 by 70 by 70. So I just click on that, type in 70, hit the tab button, which will go over to my other measurement right there, hit 70. And then I can grow this guy. Let me see. Right there. No. Oops. Undo. I could hit the front. There we go. And click on that and type in 70. Boom. And so that's going to be fairly big. So that'll be 70 millimeters. And then just the same thing. Just export it as an STL. And let me see how big honkin' that's going to be. Might be a little bit on the big side. So let me go show square. There you go. So that's going to be pretty big. One thing I have been doing, I've been trying to keep things the default because that seems to be the simplest. But there are other ways where you can save a little bit of printing filament and time. Since this is a very simple shape, not very complicated, I can go to a fast 0.2 millimeter layer, and that just means my layers are thicker. So each layer is thicker, so there'll just be less layers to print, but then you lose a little bit of detail. But with a square, you're probably never going to notice. I can also change the standard infill from 20% down to 10%, which will make it a little less filled in, but it still should be fine for this case. And again, hit generate. And there we go. Looks like should be good. And I'll save that G-code off. Same thing. And now we've got a square. Let's see. So what else we got? I'm not going to go film every single one I'm going to do here, but I just want to film a few more that may be interesting. But I will try to go create each one. Interesting one that may give you some problems is the sphere. So let me go back here. Go back to my designs. And create a new design. And we'll call it sphere. Oh, and even though I haven't done it yet, another cool thing in Tinkercad is you can share these designs. If you make some cool thing, you can actually share it and someone else can download it. So it's really, really convenient. So let me see sphere, boom. And I will go drag a sphere over here. All right. And I'll click on that and resize it. And I'll do 70 by 70, go to the front, and raise it up, and do 70. And now I've got this big old sphere. And I'll export it again as an STL file. Now the only interesting thing about this guy is it's a little I haven't actually attempted to print out a sphere yet. It's going to be interesting because it needs supports. Let me drag this in here. So if you try to print this out, it's got one infinitely small point at the bottom. It's going to try to grow from that. You can't really do that with a 3D printer. At least, everything needs it needs supports. So what I'll do here is I'll keep it fast. I'll keep it sparse. But here I'm going to do a support from everywhere. Well, from build plate. That's all it really needs. And so what it's going to do is going to determine from the build plate, from this surface down here, what kind of supports does it need to print out as well to print this guy out. So I hit generate. This should be interesting. I've never printed a sphere because that's going to be one of the hardest. I don't know. It might just be easy. I don't know. I've never done it. So as you'll see, we can go up these layers, and you'll see right there at the very bottom is just this tiny little dot. That's the start of the sphere. And all these green lines represent a lattice of support it's going to build that will help it attach this bottom of the sphere. So you can see here, print, support, 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 and it goes up, print all that extra support until it finally gets there, and then it's fine, and then it goes on. So that'll be interesting. I've never printed one of those out. So I'll save that out. There's a sphere. Okay, what else is interesting in here? And I'll go print out all of them. One interesting one that's not... two interesting ones are the triangles and the pyramids. So let me do the pyramids first. So let me go back to my designs. New design. And I'll do both pyramids on the same one. So I'll call this pyramids. Now over here, there's a pyramid. I can just drag and drop it and change the sizes. Easy peasy. 70, 70. Go to the front. Raise that up. And hit 70. Go back home and, there's a pyramid. Now over here, currently, there is no pyramid with 3 sides. So what do? Now maybe there's a fancy way you can design that in Tinkercad. I don't know. I'm still kind of new to it. But it seems like a hard thing to do. So what I actually did is I went out into Fusion 360 and I figured out how to make a 3-sided pyramid that happens to be 70 millimeters on each side and 70 millimeters tall, something like that. And so I created this, and I actually saved this file out onto my desktop as an STL file. Well, you can actually import STL files into Tinkercad, which is really cool because you could go out on Thingiverse, grab an STL file, and actually import it here into whatever you're designing. Kinda cool. So let me choose a file here, and I think it's on my desktop. Maybe. Or not. Maybe I didn't put it there. Where did I put you? Okay, maybe I need to recreate it. I'll just recreate it. So here, not that you need to, this is not about Fusion 360, so I'll make this real quick. And I'll select that, hit OK, and 3-sided pyramid. Oh, there, it's there. It's right there. Okay, it is there. Let me go choose a file and choose desktop. Right in front of my face. 3-sided pyramid. Hit open, and then hit import, and it should take a second to process it, and there is my 3-sided pyramid. Dun dun dun. Which is actually a little off on its angle, isn't it? Is it? Oh. Go to orthogonal view. Oh, no, there. Orthogonal view. There we go. The other one, if you don't use orthogonal view, you should get a vanishing point. And so that seems... Maybe I messed up that guy. I think it's okay. Okay, that seems like it might... my 3-sided pyramid might not be as correctly geometrically shaped. Yeah, it is leaning a little bit to the front, isn't it? I may have to go redesign that, but I'll Okay, I guess I didn't know as much on Fusion 360 as I thought, so I guess the tool I used wasn't quite correct for that. So I may have to go back and fix that, but I'll leave this as is for now. But the whole idea is you can import things. So now that I have that, I'll export my pyramids as an STL. Now I have my pyramids file. And I go back in here, hit back, delete that, and drag that in. And now I should have, it did it one at a time. Let me export. I had that selected. So let me select both of them. Learn something new. Select both of them and export as an STL file. Now that should work. That's good to know. If you only want to grab one piece, that's kind of nice that you can only grab one piece. There we go. My imperfect three-sided pyramid. Guessing to go figure that one out. Okay, and then generate. And there's my pyramids. Dun dun dun. Save the G-code. Let's see. Go back to my designs. Let me go do a new design with, I'll be real quick about this. I want to do the angles because we have a right angle. We have an equilateral triangle where all the sides are equal. And then we have an isosceles triangle where two sides are equal but one is not. So there happens to be a roof and a wedge over here. So I can actually drag this wedge over here. And that actually happens to be a right angle. And what I can do is I could print it out like that, which would work just fine. But if it makes more sense to you, you might want to flip it on its side. If that's the case, you can click on here, select this object, and if you hover right there, you'll see this angle shows up, and I can rotate it. And go back to my home, and now I'll see it's that way. And I can start to change my sizes, so I could do, 70 by 70, and then do this height, pull that up, and hit 70, if you want to make one that big. That's kind of big. Maybe I'll change these down here to 35. 35 by 35. But get that 70 height. There you go. And then when it comes to an equilateral triangle, you can just drag this roof over here. And then I will, let's see, if we want to make it 70 by 70. But then I want now I gotta do some math. So here if I do 70, if I do 70 like this, it doesn't matter what I do on the bottom, and I can get an isosceles triangle where these two sides are equal. But if I want an equilateral triangle, they've all got to be the same distance, so that is, you gotta remember all your c squared by a squared plus b squared equals c squared stuff. So now I gotta do some math. So I got 35. I want 70, and I want those to be equal. No, wait, that would be equal. Now we got 70. That's the problem. So if I wanted to be 70 high, you'd have to do 70 squared equals some number, which is going to be equal. I'll do the math here in a second. But anyway, that's your equilateral triangle. You have to do some math to figure out that's your isosceles triangle. You have to do some math to do the equilateral triangle. But yeah, you can make exactly what you want. Let's see. What other shapes? Okay, so those are the hard shapes. I'll go try to produce every single one. Maybe I'll even figure out a way to share them in Tinkercad so that I can post the links to those. But then you can it's just nice. You have individual ones, make individual files, and I think this is really the way to go. So I'm going to go make these, try to make them 70 millimeter-ish, print every single one out in different colors, and then hold them up and give them to my wife and see what she thinks. And I think this is really the way to go because you can customize. And all the basic shapes are there, and the few that aren't, you can probably go find on Thingiverse and just import them. So I think that's the way to go. So I'm going to go on my own and create every one and do the math and actually create the correct isosceles triangle. And I may go back and actually fix my three-sided pyramid. Then I'm just going to go print them all out and see what the results are. Okay, so I finally got everything printed out, which took several days. But before we get going, I just want to go over all the numbers on what everything cost, how long it took. So here are the totals for here's every single little thing we did, and how long it took for every single object we did. And the most expensive object we had, of course, was the giant square, because that's about, since we're doing the 70 millimeters, that's as big an object and volume as you can get, right? And so that actually cost $1.44. That was the most expensive thing we printed out. And the cheapest thing we printed out, which I found out the 3-sided pyramid is called a tetrahedron. And I was mistaken. What I actually did was correct. I thought I had done the tetrahedron incorrectly, but this is my dimensions are correct. And so that was 25 cents. And so all in all, for 14 of these objects, it came out to $7.84, which technically is cheaper than what cost online, but I don't think the point was to just be cheaper. The point was to get what you wanted. Mm-hmm. And these are bigger. I mean, if I did them the same size as those guys, this would probably be $3 or $2. And it would probably be half the time. Also, it took almost 34 hours print time to print everything out. So it took several days. But that is the numbers and everything. But yeah, so what do you think? I mean, I think, before you get on what you think, I think that getting your child involved, if they were going to do this, our kids are a little older than this. But the fact that they would make it. Not
necessarily. I mean, we've got a daughter who will be doing the, isosceles, equilateral.
Oh, true, yeah.
And she'll be also studying volume here soon. There might be a little segue into that somehow.
Yeah, but I think if you're going to do, you could use them, but I think you'd want the next step that we haven't done yet would be to print these out with like equations on the side or something.
Could be.
Or something like that.
And maybe it's just better to purchase that. That's way more accurate. I don't know. I haven't looked at that yet.
We'll see when we come to that. Mm-hmm. But, so what do you think? So we have all these guys printed out. All 14 of them. I got a red pyramid. I got half spheres. I got everything. So, I think they're pretty cool. They're a little, could poke your eye out, I guess. I didn't sand anything down or fix anything. I might, if we had little kids, I think you'd probably want to sand this down. What do you think?
Probably. And can't you manipulate that in the program to soften that corner, or no?
I can. I can really easily do it in Fusion 360. I'm not familiar enough with Tinkercad on how to.
Or you could make each
round the edges.
Yeah, each of the round edges at a certain.
If someone knows of a tool, just post and say, "Oh yeah, there's in Tinkercad. You just push this button." I'm still new to Tinkercad, so if there's a button, I'm not yet aware of it. I would think there might be something. But like right now, I would just spend 20 minutes sanding them down, because it wouldn't take long just to sand all the points off, because I'd just sand it down.
But if that's the case, you're going to have to sand. I don't know.
It should go pretty quick, because you're not wanting to sand it down to a beautiful, just to get the points off.
I think they turned out great. I love the way that I can choose what shape I want, what color I want it to be, what size I want it to be. I am pretty darn happy. As soon as we got them all printed out and he had brought them down to me, I got them all out and I just started, building like they were blocks and having fun with them like a kid. That's what a kid would do with them. They're blocks. So I probably would have printed these different colors, because.
Oh, well, you could print them again. Yeah. Right? That's the nice thing is if you don't like the color or you want more, you just print out more. You got the files, just push a button and, like this one probably cost.
How much did that cost?
A cone? Maybe we'll bring up the file I just closed. Let's see, where are you, file? Here we go. So, cone. There you go. 37 cents.
Huh.
That cost a whopping 37 cents to print out.
Nice. I really like the triangle, the different triangle shapes. Who knew? So many different triangle shapes. I really like, the pentagon. I probably would print out a hexagon and all the gons I could probably think of, because I think that's really cool to teach different different sides.
I think that's part of the dealy bob here. So if you go on, it's just a polygon, so you can change the sides.
I just think that's really cool.
You make it bigger.
So you can start out.
I can change. I can make up to 10. So.
And so you can have your kiddo really get into how many sides there's a pentagon, hexagon, all those happen. I just think that's so cool. I like how this is the same as this, but it's about half of it.
Yeah, so it should be half the volume.
I like how this, where is it? Here it is about as half as this. Show the area.
Oh yeah, the right triangle. Yeah, that's
not that one. Where's? Anyway, I was having a good old time. Here it is, the right triangle. Yeah, that's it. I was having a good old time playing with them because this is a great visual to show, the area of a rectangle or a square, and that the area of a triangle is just half of that.
There you
go. Yeah.
The only thing I liked and didn't like was I never printed a sphere. So it might be hard to show, but like this sphere is awesome. It looks really cool. But except for where it had to have supports, it's kind of a little junky right there. And there's a little support thing it printed out. So right where it had supports, it didn't do as well. But
smooth that out.
But you could sand this whole thing out and it'd probably be fine. And as is, it's okay. It's just I guess the polygon texture is really cool, but you just kind of missed that where it had where it had to build the supports. But overall, I think I don't know if there's a way to improve that, but overall it looks really cool aside from that one spun.
Well, you could print out 2 halves and put them together.
And glue them together. Yeah, but I kind of want to avoid gluing stuff together if I can. But that might be worth it because you get that really nice look.
I just think they're cool. Now, do you want me to tell you what I would change?
Yes, you would. Yes, because we talked about that. There was a slight problem.
So, being the anal person I am, this cylinder is great. Except, the whole point of a cylinder is 2 flat sides. Well, the whole point of this block would be 2 flat surfaces with a round one. Well, if you look closely, it's not really a round surface. It's just multiple flat surfaces. So this could be confusing. So I'm not so sure I like this one for teaching purposes unless I could fix that.
Yeah, I don't think it's so much of your analness, but here's a smaller one and you can see it's got, I don't know how it's going to show up. But yeah, you can see even in the Tinkercad here, it's not a perfect circle. And, it's really impossible to make a perfect circle. So you actually you cut it up more and more. So I don't know how many's on here, maybe 30, 20? I have to count, but maybe there's 20 segments on here. But you want more like 100 or 200 and it just smooths out and you can't even tell.
Yeah.
Which I can easily do in Fusion 360. And I found out there's a way to do it in Tinkercad. So I think I'm going to do a follow-up video to this to show a few other things, like how I did the tetrahedron, and also some of the other tools I found that are extra shapes that have controls on them. So you can get, somebody has put a thing out there where you can get a perfect cylinder, effectively a perfect cylinder.
Well, I know that my son had printed out a pencil holder which is essentially just a container that was round. And if he hadn't have done that, I would have been like...
You would have been satisfied.
Well, how come his can be round and this can't? But I now understand. He did that in Fusion 360.
Yeah, he did that in Fusion 360. So he tried to draw a line and had it spin around. And so it knew to do a circle perfectly. Or as perfect as can be, so you don't notice.
Yeah.
But yeah, there is and I'll do a follow-up video showing how I made the tetrahedron and also showing that there is a tool. There are some extra tools in here to get a better refinement. But I think that's valid because there could be some confusion. Because once a kid understands a pentagon and a hexagon and sees the shapes, and looks at this, well, this is a 20-agon or whatever that number is. It's not a perfect circle. And yeah, it would be better. Otherwise, it is confusing. But it does make a good foot rub.
Yes, it does.
My wife pulled her, what is that called? Your foot. She got a sword in her foot, and so she was rolling her foot on us. Which is probably good that it has, if it was a perfect circle, it wouldn't be as good. Right?
No. So can I get 50 of these? Yeah, maybe about a quarter of this size, please?
I think we should do a video on that. Is
that my next order?
That's your next order. We might do a whole video on that because you want to make a pyramid of pyramids.
I want to make a pyramid built out of pyramids.
Yeah. And it's easy to make 50 of them, but I got a feeling that you might also want to make... Layers that are attached. So there might be 9, but they're permanently attached to each other. Just
layers and then
so you
layers.
Can slap. Versus these, they might just slide.
They would slide.
Maybe. I don't know. We might
maybe you can print the bottom layer to show how they go together. Maybe 16 of them, 4x4.
Yeah, maybe just the bottom layer.
Maybe a quarter of that size.
We'll try it out. We'll figure something out. Nice thing is you can try it out because this only cost a few pennies. And if you build them half the size, they're going to cost 10 cents a piece or something. It's just a matter of time. And then you can print them all out and try it out. If it doesn't work, you waste a little bit of time. But
I think it's really cool. I don't see how kids couldn't be just so interested in printing out their own sphere and, tetrahedron and cone and that. I mean, it's one thing to see the picture on the computer. It's another to see it printing out, and then you get to play with it. The one that you created on the computer, that's pretty cool.
Well, I think if you're going to do this as a lesson plan, you're the teacher, so you'd know better than me. That would be part of the plan. You'd have the kid, you're okay, we're going to make 3 shapes. Don't do 14, because that'd be too many at first. Hey, we're going to make 3 shapes. We're going to do it in Tinkercad. We're going to make a circle, and we're going to print it. We're going to make a sphere, and we're going to print it. So they're part of the process and they get to do it. Now I think they would sink into their minds better.
And you can do a big one and then do a bunch of little ones. Make sure they're not, choking hazard size.
Yeah, don't make them small.
I just really dig these. I like them and they're all colorful and playful and I'm very happy. Sorry, we keep looking down at the desk because they're all laid out here. We all just keep playing with them.
I should have put them up higher.
Yeah, you should have.
But that is another good note. I don't know what the limit is. You were saying a paper towel tube.
No,
right?
Not a paper towel. I think back when I was younger, rule of thumb was a toilet paper tube. If it can fit in a toilet paper tube, it's too small.
So think about that. Don't make these too small because they look like candy, right? They're colorful. Kids want to stick them in the mouth, so don't make them too small.
Until they're old enough.
Or you could put holes in them. Because little Lego guys, they're tiny, but they got holes. So the big thing is a choking hazard. I'm no expert, but you might want to go look around to see what the real rules are.
Yeah.
You just want to make sure.
If you want to do small ones, and you have little kids around. Our kids are a little bit older, and so printing some of these square-based pyramids is not a concern for us because our kids are older and they know the difference. Hopefully,
no, it's not candy. Yeah, that's why we're not sanding them down right now.
Yeah.
If our kids were 5, I'd be sanding them down.
Yeah.
Because
my son has a scar right here where he landed on a square block.
Oh, he did?
Yeah.
I forgot about that.
Yeah. Anyway.
So.
Thanks, honey.
So you like them? I think that
I like them.
Yeah, so I might go post a tetrahedron or something like this, but for the most part, there's no reason to post any of these shapes or share them because Well, if someone asks, maybe I can link from Tinkercad or figure that out. So if you ask, maybe I'll figure that out. But I think the big deal is for you to do it with your kid, not just to go, oh, let's download these. Some things, hey, let's go download, like, the Bust of Caesar or the Parthenon or whatever you can find like that. But the main point of this, to learn it, is to do it with them. Or
to print out a bunch of them while they're really little so they can play with them and get familiar with them and then start to introduce the different sizes. I mean, because we're talking like preschool, preschool sometimes. So maybe you print out a bunch of them so they can start playing with them and get familiar with them. And then as they developmentally get old enough, then you start bringing out the square and say, hey, let's print out another square. And then you start talking about it. So
if they're little, they're going to chew on these.
So make them big enough.
But I don't know how. I think PLA is safe, but I don't know if kids are chewing on it.
I think so. Yeah.
I don't know. You need to go look that up before you give it to a little kid who's going to chew on it. I don't think there's any danger sticking it in your mouth, but if they're going to chew little bits off of it, I don't know. I have to go look that up. Or someone more of an expert than I am. It is made from corn and different things, so it's probably okay. It's probably food safe.
But remember, the whole point of us printing these out was for
7 to 11 years.
Yeah, third grade and up. Yeah. To introduce to some more advanced shapes. As far as the cone, the pyramid, the tetrahedron, the triangles.
Equilateral triangle.
Equilateral. Yeah. So that was mine because, I wanted more of the more higher primary grade geometric shapes.
Okay. So, cool. I like it. If anyone else has any other ideas or have made something, please share and we'll link it or show it in the next video we make, because there's a lot more cool. Even if this is, I'm not saying this is the best idea for 7 to 11-year-olds, but if we happen to have the best idea for 7 to 11-year-olds, there's definitely other ideas for 8-year-olds to 12-year-olds, or for little kids, like putting equations on the side and things like that, things that I did not do.
That would be awesome, yeah.
Super awesome. Okay, so I guess that's it for this video. More manipulatives to make. Hey, if you liked the video, please give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we were doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.